Hello, this video is for the IXL activity titled Graph Compound Inequalities. The three-character code for this activity is Bravo, Quebec, X-ray. At the time of this recording, this activity can be found in Algebra 1, Section K, and it is Activity 12. All right, so compound inequalities. What are compound inequalities? Well, we've been working with inequalities so far. Like, for instance, if you look over here on the right where my highlighter's at, we've worked with things like x is less than 61, and we've graphed that before. It'd be the left side of what you see here on this graph here, where we plot 61, and all the numbers less than 61 are to the left of it, and it should be an open dot because it doesn't have the equality concept and with the inequality symbol. And it's just less than, not less than or equal to, so we leave this as an open dot, and we graph everything to the left. Now we're dealing with compound inequalities. Well, what does the word compound mean? Well, if I think of a compound fracture, that means if I had broke my arm and I had a compound fracture, that means I have more than one break in my arm. Both bones are probably broken. If I have a compound, chemical compounds, or whenever we have two or more chemicals that are bound together to form a substance, and that would be a chemical compound. So think of compound as more than one. Well, in this case, we're going to have two different situations. We have something that looks like this over here on the left, where we have x is greater than -5 and x is less than -2. And we can see that here that, or actually less than or equal to, but we can see that here that everything that's shaded here, that all this area here that we would call x, it is indeed greater than -5, but it is also less than -2. So that's where we get and. It's this and that. And we'll talk about that some more in a little bit. Then there's the or situation over here where we have x is less than 61 or x is greater than 62. Now there's some tricks I'd like to teach you real quick that kind of helps you figure out how to graph each one of them, because you'll notice that one of them looks like a barbell, right? Looks like a bar with maybe weights on each end. And the other one is like two separate arrows pointing outward. And how do we spot each one of those? How do we know which situation is what? And we're going to go ahead and talk about that. Let's first talk about the one over here on the left. We would read this as x is greater than -5 and x is less than or equal to -2. And we can see that from the graph here. Just talked about that a moment ago. Well, it has like three parts to it, right? It has the x in the middle, or the variable in the middle. It has a value on the left and a value on the right. And the word and has three letters in it, A, N, D. So we can match up the A with three elements. Think of it as like three elements in it if we don't count the signs. So A is the number on the left, N is the variable in the middle, D is the number value on the right. And likewise, whenever we create this barbell looking type graph, we have two endpoints, the A and the D, and then we have the bar in between, which would be the N. So think of it this way, is that if you see a situation like this, three parts, A, N, D, then you get three parts, endpoint, line, endpoint. Things to note is that the signs always point to the left. Whenever they're set up like this, the sign is always going to point to the left, and the lesser value is on the left. Notice that -5 is less than -2, so we have it over here on the left. So that's an and situation. Now let's talk about an or situation. Well, you probably see my picture down here in the little or, double arrow, or, O-A-R. And just like the word or, O-R, sounds like the word or, O-A-R, like the oars on a boat. And whenever we graph this, what does it look like? It looks like an oar pointing to the left and an oar pointing to the right. So we end up with two oars. And in the statement, we're always going to have the word or. Over here, sometimes they'll put the word and in there, and we'll look at some situations like that. But usually an and statement's written like this, but an or statement has the actual word or in the statement itself. And the thing about it is the ors always point outward. Whenever it's written like this, notice that the symbols are pointing outward, just like the ors are pointing outward. And also the lesser value is on the left. So just like over here with the and situation, the lesser value is on the left and the greater value is on the right. However, the variable always comes first. So over here on the left with the left OR, you list the variable first. Over with the right OR, the variable gets listed first. So those are some important things to remember. So in review, in AND situation, there's three parts, A, N, D, A, N, D. We can tie all that together with the word AND, three parts, three elements, and three parts to the graph, two endpoints in a line. With the OR situation, or like oars on a boat, we know the graph is going to have two arrows pointing outward, and that we're going to have the lesser value on the left, the greater value on the right, and the variable always comes first, and the symbols also point outward as well. So we'll keep all that in mind as we move on. So let's go ahead and take a look at some examples here and see how we can do with them. So on the first one, it says graph the compound inequality, and we have here -2 less than or equal to x less than 4. But I recognize this as an AND statement, A, N, D. So I know it's going to form one of those barbell looking line things. It's going to be a solid line with a couple endpoints. Now, the thing about it here is that we want to make sure that the lesser values on the left, the greater values on the right. Check. Good to go. Both the arrows pointing to the left, indeed they are. The next thing we need to determine open dots or closed dots. So let's go ahead and get our pen here. And first one's going to be -2, so we're going to find that, put our dot here. And should it be open dot or closed dot? Well, it does include the equality concept, so I want to go ahead and fill that in with a closed dot. Over here for the other sign, I have 4, so let's find that. And it's right here, so I'll go ahead and mark that in. And it does not have the equality concept in there, so I'll leave that one blank and or hollow, open I should say to be exact, and then I'm just going to put a line in between there. And now I have my three parts, endpoint, line, endpoint, A, N, D, -2, check, 4, check, equality concept, closed dot, no equality concept, open dot, I'm good to go. Let's look at the next one. This seems to be an AND situation. I have three parts, A, N, D, number value, variable, number value. Is the lesser value on the left? Indeed it is. 1 is less than 3. Are both the arrows pointing to the left? Indeed they are. This is an AND situation. So let's go ahead and find our value of 1. Good. Open dot or closed dot? No equality concept, so we'll leave this as an open dot. What about the other one? Open dot as well, right? We want that at 3. So I'm going to go ahead and put an open dot at 3 and then connect those two with a line. Next two examples, well, right away, one thing we notice is that they have the OR statement in it, right? So we know that these should be two arrows pointing outward like the oars on a boat. Now let's do a couple of checks here. First, we want to make sure is the lesser value on the left and the greater value on the right. Well, 883 is less than 888. Good to go. Are both the arrows pointing outward? Indeed they are. Do the variables come first on both of the statements? Left OR, variable comes first. Right OR, variable comes first. So everything's good to go. Let's go ahead and start graphing this. So we want to find the point 883 on the line, and it does have the equality concept, so we want to put a solid dot at 883 right there, fill that in. And then over here for the next one, we have the equality concept, so it should be a solid dot as well. Let's find 888, go ahead and graph that, solid dot, and we know that this is an OR situation, so these are like oars on a boat. We'll put our oars facing outward. And there we have the graph for this compound inequality. Next example, another OR situation. Let's go through, make sure everything's good to go. First of all, is the lower value on the left OR. 144 is less than 154. Good to go. Are both the oars pointing outward? Are both the signs pointing outward? Indeed they are. Do the variables come first on both of the oars? Here and here. Good to go. Let's go ahead and graph it. First point over here with 144, no equality concept, so it should be an open dot. So we'll go ahead and put an open dot here. On the second one, we're looking for 154. Here it is right here. Equality concept is there, so it should be a closed dot. We'll go ahead and fill that in. And we know this is an OR situation, so we want our ORs facing outward on each side. And we now have successfully graphed this compound inequality. Let's look at the next example here. Ah, tricky, tricky, tricky. They have the word and here. Well, we know with an and situation that we can set this up in another way. It doesn't have to use the word and. Or situations, compound inequalities that are or situations where the graphs point outward, they need the word or. But we can rewrite an and statement without it. We know that with an and statement that we have a variable in the middle, correct? We also know that with an and statement, both of the ors point to the left, and the lesser value goes on the left. So -4 is less than -3. And now over here with the one that's a -3, we see that this should have the equality concept. The one over with -4, not so much. It's an open dot, right? It's just less than. Now let's go ahead and look and see, did we keep everything squared away whenever we piece this thing together into this statement? Are they both the same statements? In this case, we have the x, and I want you to focus on, check out this part of it, and we kind of have two separate statements together. We have one where we have the variable x with the -4 and an inequality statement. So we could rewrite this as, right, x is greater than -4. We know we could switch them around. Does this look like something we see up top? Indeed it does. Right there, we're good to go. So we know that this part right here is the same as that, which is what we see right here. Now what about the part underlined in yellow? X is less than or equal to -3. Well, indeed, we have that right there. So we've taken this and statement and we've put it together in something right here that looks like what we've seen in the other examples with and statements. So from there, let's go ahead and graph it. It's an and statement, so it should look like a barbell, correct? So let's first find -4. We want to find -4. There it is on the number line. So let's go ahead and we'll graph that one in. Open dot or closed dot should be an open dot, right? No equality concept. The other number is -3. Let's go ahead and find that. And this should be a closed dot, has the equality concept there. And we know this is an and situation. So we know we're just going to connect them together with the little bar there. It's kind of a short answer. It's not a very big graph, but it is the correct one. Moving along to another situation. Here's another one just like that. So let's go ahead and get some practice on setting that up. We know that we have the variable in the middle with an and statement. With and statements, both the ors face to the left. So make both both of our arrows. The ors are in the or statement, but both of our arrows point to the left. The lesser value goes on the left. 50 is less than 150. So let's put 50 here, 150 over here. And where we got the 50, we should have the equality concept, so we'll put that there. And with the 150, no equality. We don't need half an equal sign there. So let's go ahead and double check. Have we done this correctly? We have one statement that says 50 is less than or equal to x. We have another statement that says that x is less than 50. We know that we can rewrite this half over here, put the x on the left and the 50 on the right. And I'm trying to write with the line. There we go. Works on part of it, but not everything. And then we want to flip it, right? So does this right here look like that part up here? Indeed it does. So we got that, and that's the same as what's underlined in red. Then we got x is less than 150. We have that here in the yellow. So we got it all set up. We know this is an and situation, so it's going to look like one of those barbell type things, right? So let's find 50 and graph it. 50 is right here. Open dot or closed dot. We see we have the equality concept. We want a closed dot. And then we have x is less than 150. So let's find 150 on the number line here. There we go. Open dot or closed dot. No equality concept, so it's an open dot. It is an and situation, so we know that we connect these two so that we can make our little barbell looking thing there. There we go. Thicken that line up just a little bit. And we're good to go. I think I have one more example. Indeed, I do. And this is an OR situation. So let's go back and think. The ORs face outward, so we know with an OR situation, we're going to have a graph where they both go out. So let's double check and make sure that everything's set up correctly. First of all, is the lesser value on the left OR? 280 is less than 340. So the lesser value is on the left OR, the greater value is on the right. Are the ORs facing outward? To the left and to the right. So the ORs are facing outward. Do the variables come first in both of the ORs? The X comes first, the X comes first. Everything's set up. Let's go ahead and graph it. Over here for the left OR, do we need an open dot or a closed dot? Well, no equality concept, so it's going to be open dot at 280. And over here for the 340, it has half an equal sign, so we need a closed dot here. So we're going to go ahead and close that one there and include the point 340. And we know this is an OR situation, so just like the oars of the boat are going to face outward, indeed, we're going to face our oars going outward. So those are all of my examples for the activity titled Graph Compound Inequalities with the 3-character code Bravo, Quebec, X-ray. Good luck with your activity.